Hi, I am Revathi, Assistant Professor, Department of EEE, SNS College of Engineering. In this lecture series video of electron devices and circuits, today's topic is IGBT switching characteristics. So, switching characteristics of IGBT is where the typical switching characteristics of IGBT is explained in the diagram, whereas the Z get, V get, and V get offset is explained in the graphical wave format, where the switching characteristics is turn on time T on is composed of two components as usual, delay time and the rise time. Delay time is defined as the time in which collector current rises from leakage current to 0.1 IC, final collector current, and collector emitter voltage falls from VCE to 0.9 VCE. Rise time is defined as the time in which collector current rises from 0.1 IC to IC and collector emitter voltage falls from 0.9 VCE to 0.1 VCE, where this is explained in the graphical waveform, where the rise of potential is rises from 0.1 and reaches to IC current and reaches 0.1 IC and then falls for 0.1 IC, where the turn on off time consists of the three components: delay time, initial fall time, and the final fall time. Delay time is defined as the time when collector current falls from IC to 0.9 IC and VCE begins to rise. Initial fall time is the time duration which collector current falls from 0.9 IC to 0.2 IC and the collector emitter voltage rises to 0.1 VCE. The final fall time is defined as time during which conductor falls from 0.2 IC to 0.1 IC and 0.1 VCE rises to final value VCE. So the graph represent all these steps where rise from 0.9 to drop from 0.1 ICs, where the main advantage of IGBT over power MOSFET and BJTs are: IGBT is very low on-stage voltage drop due to conductivity modulation and has superior on-state current density. So smaller chip size is possible and the cost can be reduced. Low driving power and a simple drive circuit due to the input MOS gate structure. It can be easily controlled as compared to current control devices, thyristor and BJT. In high voltage and high current applications, wide SOA, it has superior current conduction capability compared with the bipolar transistor. It also has excellent forward and reverse blocking capabilities. The main device limitations drawbacks are: switching speed is inferior to that of a power MOSFET and superior to that of a BJT. The collector current tailing due to the minority carrier causes the turn off speed to be slow. There is a possibility of latch up due to the internal PNPN thyristor structure, where the safe operating area SOA are defined as the current voltage boundary within which a power switching device can be operated without destructing failure. For IGBT, the area is defined by the maximum collector emitter voltage VCE and collector current IC, within which the IGBT operation must be confined to protect it from damages. The IGBT has the following types of SOA operations: forward biased safe operating areas, reverse biased safe operating areas, and short circuit safe operating areas. Where the forward bias safe operating areas are important characteristics for applications with inductive load. The charge determines the electric field distribution to the drift region in steady state forwarding blocking condition. The drift region changes to equal to ND. In FBSOA, the next charge is much larger because the whole current density is significantly larger than the electron current density. Reverse biased safe operating areas are, it means 1200 amps IGBT is able to turn off a maximum current of 2400 amps. The maximum current in the function of the peak voltage which appears between collector and emitter during turn off. The peak value of VCE is the sum of the DC link voltage and the product of LCI DCE. In the mode, the gate bias is at 0 or at a negative value, thus the current transport is the drift region occurs exclusively via the holes for an N-channel IGBT. The presence of holes adds charge to drift region. The result in increase in electric field at a P-base N-drift region junction, where the drawback junction is defined in the graphical representation. A short circuit safe operating area, a very important required imposed on the power switching device when user is motor control application, is that able to turn off safely due to the load or equipment short circuit when a current overload occurs. Collector current rises rapidly until it exceeds that which the device can sustain with the applied gate voltage. The key to survivability for the power devices is to limit the current application's amplitude to a safe level for a period of time that is sufficiently long to allow the control circuit to detect the fault and turn the device off. The IGBT collector current IC is a function of a gate emitter voltage and the temperature T, where the circuit diagram for SVSOA test is shown. The short circuit inductance value determines the mode of operation of the circuit. When it is the range of UH, and the operation is similar to normal switching of inductive load. When IGBT is turned on, VCE drops to its saturation voltage. The IGBT must be turned off within 10 US to prevent destruction due to overheating. Assessment. The voltage blocking capability of the IGBT is determined by the controlled parameter in IGBT is the major drawbacks of the first generation IGBT was that the structure of the IGBT is thank you.